Let's continue now with a look at some larger scale projects, funding for larger scale geothermal energy.
Geothermal energy utilizes what is called heat mining, which, through a simple process using water, is able to generate massive amounts of clean energy. In 2006, an MIT report on geothermal energy found that 13,000 zettajoules of power are currently available in the Earth, with the possibility of 2,000 zettajoules being easily tappable with improved technology. The total energy consumption of all the countries on the planet is about half of a zettajoule a year. This means about 4,000 years of planetary power could be harnessed in this medium alone. And when we understand that the Earth's heat generation is constantly renewed, this energy is really limitless and could be used forever. These energy sources are only a few of the clean, renewable mediums available, and as time goes on, we will find more. The grand realization is that we have total energy abundance without the need for pollution, traditional conservation, or in fact, a price tag. And what about transportation? The prevailing means of transportation in our societies is by automobile and aircraft, both of which predominantly need fossil fuels to run. In the case of the automobile, the battery technology needed to power an electric car that can go over 100 miles an hour for over 200 miles on one charge exists, and has existed for many years. However, due to battery patents controlled by the oil industry, which limits their availability to maintain market share, coupled with political pressure from the energy industry, the accessibility and affordability of this technology is limited. There is absolutely no reason other than pure, corrupt profit interest that every single vehicle in the world cannot be electric and utterly clean, with zero need for gasoline. As far as airplanes, it is time we realize that this means of travel is inefficient, cumbersome, slow, and causes far too much pollution. This is a maglev train. It uses magnets for propulsion. It is fully suspended by a magnetic field and requires less than 2% of the energy used for plane travel. The train has no wheels, so nothing can wear out. The current maximum speed of versions of this technology, as used in Japan, is 361 miles per hour.
We need to remember too that the magnetic field that the maglev depends on is generated by the geothermal nature in the mantle of the Earth.
However, this version of the technology is very dated. An organization called ET3, which has connections with the Venus Project, has established a tube-based maglev that can travel up to 4,000 miles per hour in a motionless, frictionless tube, which can go over land or underwater. Imagine going from LA to New York for an extended lunch break, or from Washington, D.C. to Beijing, China in 2 hours. This is the future of continental and intercontinental travel. Fast, clean, with only a fraction of the energy usage we use today for the same means. In fact, between maglev technology, advanced battery storage, and geothermal energy, there would be no reason to ever burn fossil fuels again. And we can do this now if we were not held back by the paralyzing profit structure.
Let's take a look at the current situation now. Back to Earth now.
The geothermal development company GDC, which was set up 2 years ago, has already procured 2 geothermal drilling rigs to enable it to exploit the resource. The 2 rigs will cut the cost of drilling geothermal wells by up to 50%, enabling the country to intensify efforts to exploit the resource. GDC, which is mandated to exploit geothermal power to enable power generation companies set up power plants, is expected to begin drilling in the Menengai crater, which holds a 1,000 megawatt potential.
The government was able to finance the procurement of these 2 rigs.
1,000 megawatt potential.
These rigs will start drilling in Menengai. That will be the first field in which we are going to do the drilling starting next week.
Unlike in the past where various wellheads had to be drilled before power plants could be set up, GDC intends to utilize the wellhead generation technology to enable immediate exploitation of power. This new technology will enable Kenyan investors to set up their own power plants at lower cost, hence opening up the power generation industry to wider investment opportunities.
Geothermal Development Company will manage these wellhead units on behalf of the investors, so that with that approach, the investor doesn't have to be an expert in geothermal development. The investor only needs to have the financing.
The country's capital, Nairobi, is expected to see an expansion in investment as the construction boom continues to grow, and with similar investments expected across the country as the counties come into effect. Kenya will require additional power that can only be satisfied by development of geothermal power.
We should be having close to 2,000 megawatts. And our plan for example, for Menengai is that by 2014, 2015, that we should be having the first 400 megawatts online.
Geothermal power, which is a relatively cheaper source of power, is expected to bring down the cost of electricity in the country. Henry Githaiga, Citizen Business.
Hey, all right, guys. They're doing it in Kenya, huh? Nice. So what is Swiss Metro up to here? Based in the maglev that we talked about, this underground mass transit in the planning stages. Actually, I think they have a portion of it in service currently.
A new means of underground transport similar to a wheelless train or a wingless aeroplane, able to carry passengers in perfect safety at over 500 kilometers an hour? That's what Swiss Metro is proposing. Follow us in this adventure and discover why, with Swiss Metro, the future is now. The idea of Swiss Metro was born in Switzerland to provide a remedy for the saturation of the road and rail network without spoiling the landscape. Swiss Metro proposes a new, completely underground form of passenger transport based on the very latest technology, highly ecological and environment friendly. It will travel at over 500 kilometers an hour in small diameter tunnels situated some 50 meters below the surface connecting the main cities, firstly of Switzerland and subsequently of Europe and, why not, of other continents. It will be driven by linear electric motors and will glide on magnetic levitation without any contact with the track.
Do you suppose there will be, suppose there might be some kind of median temperature going on down there? It might be a little bit cooler. Don't have to worry about weather. Yeah.
Moreover, given the reduced air pressure in the tunnels, it will save considerable amounts of energy. Passengers will buy their Swiss Metro tickets at railway stations in city centres for fares very similar to those which would be paid for intercity trains. After passing the checking gate, they will take the lift down to the boarding station, some 50 metres below street level. system of airlocks will hold the vehicle hermetically attached to the embarkation zone, permitting passengers to board without noticing the partial vacuum in the tunnels.
Il nostro personale è a vostra disposizione per ogni informazione.
Passengers will take their seats in the modern Swiss Metro shuttle and will reach their destinations in just a few minutes.
Benvenuti a bordo. Prossima fermata tra 13 minuti. Lucerna.
Fully automatic vehicles fitted with all modern conveniences will carry 200 to 800 seated passengers and will leave at intervals of less than 10 minutes. In order to reach high speeds in complete safety, the Swiss Metro vehicle will be driven by a linear electric motor. The classic electric motor comprises a coil, the stator, which, fed with an alternating electric current, causes an enclosed ferromagnetic rotor to spin. By unrolling this structure, a linear motor is obtained, characterized by a ferromagnetic core which, instead of spinning, glides across the coil without touching it. In the case of Swiss Metro, the mobile part of the motor will be fixed to the vehicle, while the static part will be located along the tunnel. Launching a shuttle underground at over 500 kilometers an hour requires another advanced technology that eliminates wheels and contact rails, the magnetic levitation and guidance system. A series of electromagnets fixed to the shuttle, combined with a reaction ferromagnetic rail laid along the tunnel, will be able to raise the shuttle up to 2 centimeters from the track and keep it constantly in the optimal position by regulating the force of attraction of the magnets. Finally, to reduce aerodynamic drag and keep the tunnel diameter as small as possible, it will be necessary to evacuate air from the tunnel, creating a partial vacuum similar to atmospheric conditions at an altitude of 15,000 meters. This will ensure optimal energy consumption, making Swiss Metro both an economical and an ecological form of high-speed transport. Indeed, if we take account of the occupancy rates of all means of transport, Swiss Metro will be far faster and cheaper than car or train. This great advantage will undoubtedly count towards its success. After having covered approximately 100 kilometers in under 15 minutes, the Swiss Metro vehicle reaches the next station. In just 3 minutes, passengers disembark, others board, and the vehicle is off to the next stop. At the terminal, there is a special turntable, like the cylinder of a revolver, which can swing the vehicle round from one tunnel to another, ready for immediate departure in the opposite direction. The Swiss Metro system is initially planned to be developed in Switzerland, forming a national network crossing the country from east to west, from Geneva to St. Gallen, and from north to south, from Bâle to Bellinzona, with later additions to Sion and Chur. The high speeds that Swiss Metro can reach will enable it to cover the distances between Swiss towns in as little as 12 minutes, thus making Switzerland one single large metropolis. Subsequently, the national network is to be extended beyond Swiss borders, so that Swiss Metro will become a true Eurometro, linking Munich to Lyon or Amsterdam to Milan. The first leg of the Swiss Metro network is planned to link the international town of Geneva to Lausanne, where Swiss Metro was born, along the shores of Lake Geneva. This phase could be up and running by the year 2010. The trip of about 60 kilometers will last less than 12 minutes. The idea of Swiss Metro was conceived in Switzerland to overcome saturation on road and rail. Indeed, because of the mountainous nature of the country and the high population density, together with restrictive environmental protection laws, the creation of new surface means of transportation appears very difficult nowadays. So an underground transport system is the only possible solution remaining.
Yeah, alright guys.